This problem says find y prime by using the quotient rule and by simplifying and using the power rule. So first, let's try doing this with the quotient rule. If you remember what the quotient rule is, just to recap, let's say that you have a function which is u over v, the y equals u over v, where they're both functions of some variable x. Then y prime equals, now the mnemonic that I use sounds like this. You know, the denominator is lower than the numerator, so I say low d high minus high d low over low low, and you'll see how this applies. I said low, so that's just v, and I said d high, which means the derivative of the numerator, minus high d low, which means the derivative of the denominator function, over low low, which means the denominator function squared. So you do the denominator function times the derivative of the numerator function minus the numerator function times the derivative of the denominator function, all over the denominator function squared. Low d high minus high d low over low low. It's just a funny way to remember it, but once you've done enough of these problems, you probably will just remember it. So let's do the quotient rule using this blue marker. We want to know what the derivative of this function is. I said low, so x fourth times, what's the derivative of x squared plus 1? Well, this is a sum, and this one is just the power rule. 2x plus the derivative of a constant is 0, so there's nothing left, minus the numerator function is x squared plus 1. Now the derivative of x to the fourth using the power rule is 4x cubed. There we go. And x to the fourth squared is x to the 8th. Let's see. Let's multiply through here. So this is 2x times x to the fourth, so this is 2x to the 5th minus, 4x cubed times x squared is 4x to the 5th. And this is plus 1 times 4x cubed is 4x cubed, all over x to the 8th. Okay, now let's distribute through the minus sign. 2x to the 5th minus 4x to the 5th is negative 2x to the 5th. Because 2 minus 4 is negative 2. Now minus 4x cubed is just minus 4x cubed, all over x to the 8th. We can simplify now over here too, because minus 2x to the 5th over x to the 8th is minus 2x to the negative 3rd, minus 4x cubed over x to the 8th is 4x to the minus 5th. So this way, solving it using the quotient rule, we get negative 2x to the minus 3rd minus 4x to the negative fifth. What if we simplify this first? Well, then y is equal to x squared over x to the fourth is x to the 2 minus 4 is negative 2, plus 1 over x to the fourth is x to the minus fourth. So now this is another way of writing y. Now we can just use the power rule on each of these. What's the power rule? X to the negative 2 is negative 2x to the negative third, plus the power rule applied to x to the negative fourth is plus negative 4. I'm just going to put this minus 4x to the negative fifth. And now we can compare the two answers, and they're the same. This function says let f and g be differentiable functions with f of 2 is 3, f prime of 2 is negative 1, g of 2 is negative 5, and g prime of 2 is 2. And we've got to find g minus f prime of 2 and 4g prime of 2. So we have to interpret this notation. What does this mean? What does it mean if I had two functions, f and g, and I put this? What does this mean? What's another more explicit way of writing this? Well, turns out that this type of notation is the same meaning as okay. So it means, because when you're doing combinations, specifically a sum of a function, then it's the sum of the function on each one. But what is this? What happens if we do? Let's just start with this problem right here. What is g minus f? What does this mean? Let's use a different notation right here, because we're taking the derivative of the difference of the functions. We could also write it as this. It means take the derivative of the difference of the functions. But now we need to recall the rule for additions and sums of derivatives. Do you know how to do this, what this is equivalent to? It's beneficial to look at the proof, but it turns out that the derivative of a difference is the difference of the derivatives. So this is equivalent to, I'm going to go flip back to the original notation that we're using here. Okay, so in this problem, it means that we're saying g prime of 2 minus f prime of 2. Okay, what is g prime of 2? What's the derivative of g's value at 2? It's equal to 2 minus, what is f prime's value at 2? It's negative 1. 2 minus negative 1 is 2 plus 1, which is 3. Okay. Now, what does this mean for some value x? Well, we're taking the derivative of what's in the parentheses, so we can use the d dx notation to say okay. And now there's the theorem, the useful theorem that says you can pull a constant out of a constant times derivative expression. So this is equivalent to 4 times the derivative of g of x. Now this we can directly work with because we know that this is the same thing as 4g prime of x. Okay, so this is equal to 4 times, what's g prime of 2? It's 2. So that means that 4g prime of 2 is 4 times 2, which is 8. This problem just says find f prime of t, where f of t is 12 minus 3t to the 4th plus 4t to the 6th. This is very easy once you've seen and proven the power rule and you know that the derivative of a sum or difference is the sum or difference of the derivatives. So we just write f prime of t equals, okay, the derivative of a constant is 0 because the function is a flat constant line. I'll just put 0 right here, minus 3t to the 4th. So we've got 4 times 3 is 12. T gets reduced from 4 to 3. Plus 6 times 4 is 24. T6 gets reduced to 5. So we can get rid of the 0 and just write negative 12t cubed plus 24 t to the 5th. That was a quick one. This problem says find g prime of r, where g of r is 5r minus 4 quantity to the negative second. Now, you can't directly apply the binomial theorem here, and although there is a very useful, extremely useful theorem called the chain rule, we're going to assume that you don't know that yet. So we have to figure out a way to convert this into a form that we can use what we know, which are things like the product rule and quotient rule. What does a negative exponent mean? It means that it's in the numerator or the denominator. It means that we can write g of r like this, right? Yes, because 2 exponent, the reciprocal, that means the same thing as negative 2. Now this we can do something with using the quotient rule. How would you first make this? We want to expand it, right? So we can use the binomial expansion here. Numerator is still 1. So 5r minus 4 squared. What's 5r squared? 25r squared, right? Okay. Now, since a plus b, a plus, let's do minus because this is a minus problem. Subtraction. A minus b squared. This is a squared minus 2ab plus b squared. We already found out 5r quantity squared is 25r squared. What is a? 5r. What is b? 4. What do we put in front? Minus 2. Okay. 2 times 5 is 10. 10 times 4 is 40. So we got minus 40. Don't forget the r. Okay. Plus b squared. B squared. What's b? B is 4. What's 4 squared? 16. All right. Now this function, now let's remember what the quotient rule is. Let's call v over u. And we want to know what's the derivative of that type of function. Remember, it's low d high, so it would be u v prime minus, now you take the top function times the derivative of the lower function over u squared. Now, keeping this in mind, what is the derivative of the top? The top is a constant, 1. So we don't need to write this out because we know the derivative of this is 0. So 0 times this is going to be 0. So this is going to be 0 minus. So we'll just write minus. Okay. What is v? The numerator function is just a 1. So instead of writing a 1, we'll just not write a 1. Now we need to take the derivative of the bottom function. This is fine. It's a polynomial. We can use the power rule here. 25r squared will be 2 times 25r. 2 times 25 is 50. We got a minus. What's the derivative of 40r? Well, this is just a 40 because r is r to the first. 1 times 40 times r to the 0th. R to the 0th is just 1. So this is minus 40. And what's the derivative of 16? 16 is a constant, so its derivative is just 0. Now, what would you rather square? This or this? They're the same thing, but which one is nicer to do? This one. We can write 5r minus 4 squared squared is just going to be to the 4th power. We could write this, we could leave this as it is, or we can distribute the minus sign. This is minus 50r plus 40 over 5r minus 4 to the 4th. This problem says find g prime of v, where g of v is v cubed minus 1 over v cubed plus 1. So, nice quotient rule problem. Do you remember the format of the quotient rule? Let's start. We know that it is in the form of a fraction. And the first one of these is one of these left alone times the derivative of the other. Which one is left alone? It's this one, right? So we're going to start v cubed plus 1 times the derivative of this. What's the derivative of v cubed minus 1? Well, this constant isn't going to be there. This is a power rule problem. The derivative of v cubed is what? 3v squared. And from the format of the quotient rule, we know the next thing to do is subtract. Now, this first term was low d high minus, now we do high d low. Remember the v cubed minus 1. What's the derivative of v cubed plus 1? That's just going to be 3v squared. And in the denominator is the denominator function squared. So we've got v cubed plus 1 squared. Now, let's simplify the numerator. We've got 3v squared times v cubed. That's just going to be 3v to the 5th, right? And we've got plus 1 times 3v squared, so it's going to be plus 3v squared. Now we've got this minus. So let's put some parentheses here. What's 3v squared times v cubed? We're just going to add the exponents. So we've got 3v to the 5th. And we know a minus is just going to be a plus. Now, what's 3v times 1? Because I've already taken care of the minus symbol. So what's 3v times 1 is just 3v squared. 3v squared times 1 is 3v squared. All of it over v cubed plus 1 squared. Okay. Now we can see a 3v to the 5th and a minus 3v to the 5th canceling out. And we got a 3v squared and another 3v squared, so they add together. So the answer is 6v squared over v cubed plus 1 quantity squared. This problem says g of 5 is 3 and g prime of 5 is negative 2. So we don't even know what these functions look like. We just know the values at 5 and the values of the derivatives at 5. Okay, h of 5 is 7 and h prime of 5 is 10. And what we want to know is gh prime of 5. So remembering the notation, what does this mean right here? What is it? Of any value, what is this notation equivalent to? This is a combination, this is a product of two functions. So and we want to know the derivative of the, this is another way of writing it. So here we have a problem where we have the derivative of the product of two functions. This is where you want to understand the product rule. And I recommend you go search up a proof, work it out yourself, and see how it works. We're going to use it right here without proof. Turns out that the derivative of a product of functions, assuming that the functions are differentiable, turns out that it's g prime of x times h of x plus g of x times h prime of x. It's easy to remember, it's nice and symmetrical. All you have to do when you're taking the derivative of the product of two functions is do the derivative of one times the other times the one times the derivative of the other, and you add them. So going back to this problem, what would this be? What is g prime of 5? So we're talking -2. What is h of 5? It's 7. We're going to add. So now we want to flip the derivatives we're doing. So what's g of 5? We're given that that's 3. Now we want to take the h prime of 5, which is 10. Okay, what do we have here? -14 plus 30. Can you do that? What's 30 minus 14? Would it be 16? So gh prime of 5 would be 16.